Hello, good morning or good afternoon to everyone. Welcome to a new edition of Smart Talks by MESPAC. This time it is a pleasure for us to present this webinar by the hand of Herrmann, one of our stellar partners. I am Monica Cuatracasas, a communication manager at MESPAC. Nice to greet you. And today we are delighted to have you join us for this session entitled Smarter Ceiling Performance with Ultrasonics, where we will discover how ultrasonic technology from Herrmann transforms pouch sealing as faster, cleaner, and greener. This webinar is scheduled to last approximately 45 minutes and will be presented by our experts, Miriam Materna, Specialized Product Management at Herrmann, and Victor Boguña, Sales Engineering Manager at MESPAC. Following the presentation, we will allocate around 10 minutes for questions and answers, so please feel free to submit your question writing during the session through the questions answer section below. This session will be recorded and shared with those who have been registered later. So, let me introduce, first of all, Miriam Materna from Herrmann. With a strong background in packaging technology and product development, Miriam brings extensive expertise in ultrasonic sealing applications. At Herrmann Ultrasol, she focuses on optimizing sealing processes for sustainable packaging solutions, and her hands-on approach and technical knowledge help customers implement reliable and efficient ultrasonic systems customized to evolving industry demands. Good morning, Miriam. Glad you are here with us today. How is it going?
Hi, Monica. Thanks for inviting me. I'm very happy to join and I'm excited to have this webinar today. Thank you.
That's a pleasure for us. Thank you, Miriam. And now I'd like to introduce Victor Boguña from MESPAC. Victor joined MESPAC over 4 years ago, beginning his career with the company as an automation engineer associate. Thanks to his dedication, technical expertise, and customer-centric approach, he has been promoted to a role of sales engineering manager. In his current position, he leads a solution sales department where he plays a key role in aligning cutting-edge technology with client-specific needs. Victor has had the opportunity to travel extensively, working closely with international customers to design and implement customized packaging solutions that meet the highest standard and of innovation and efficiency. Good morning, Victor. How are you today?
Morning, good afternoon to everyone. Pleasure to be here.
Thank you, Victor. So thank you both for your contributions to this session. And with nothing further to add, let's proceed with the presentation. So we will start, but very quickly, with a short presentation of introduction of MESPAC. But this will be very short because the topic here today is for the ultrasonic sealing. But first, let me introduce who we are. And MESPAC, headquartered in Barcelona, is a global leader in flexible packaging and equipment for consumer packaged goods, and we are known for our innovation in creating sustainable packaging solutions. MESPAC has been part of Duravan since 2015, a leading player in the world of industrial equipment headquartered in Illinois. Duravan is a global engineered equipment company with manufacturing, sales, and services facilities throughout North America, Europe, and Asia. Here you can see in this slide that Duravan offers immediate and lifelong aftermarket support across different sectors, food sorting and handling, protein processing, packaging equipment, and material handling industries worldwide through its diverse portfolio of operating companies and brands that you can see here in this slide. About MESPAC, established in 1994 as horizontal form fill and seal manufacturer, MESPAC has evolved into a global one-stop shop with intensive services, with sales teams in over 90 countries and regional services centers, ensuring prompt access to parts. We boast the industry's largest product portfolio, with 380 employees across 17,070 square meters of facilities. Our production centers are in Spain, the US, and India. And here in MESPAC, we provide solutions for various industries, including food, beverage, pet food, pharmaceuticals, personal care, and home care, especially. But additionally, we serve more industries such as lawn and garden, agriculture, tobacco, automotive, and more. At MESPAC, our talented engineering team designs customized integrated solutions for primary, secondary packaging, and end-of-line processes. With our extensive portfolio that you can see here, we offer high precision, efficient, and versatile horizontal form, fill, and seal machines for flexible packaging, including machinery for pre-made pouches and a wide range of vertical form, fill, and seal equipment. Additionally, we provide hydroforma machines for water-soluble pots and end-of-line equipment to fit your secondary packaging needs, offering targeting solutions it is required. So at MESPAC, we are committed to sustainable packaging solutions that prioritize environment responsibility, and our focus is on developing monomaterial packaging options which are easier to recycle and reduce waste. So this marks the beginning of our introduction to MESPAC and providing you with the opportunity to familiarize a little bit yourself with who we are. And now, Miriam, I will pass the floor to you.
Thanks, Monica. So let's go on with the company introductions. So I would like to introduce Herrmann Ultraschall now. Herrmann Ultraschall is a family-owned company based in Carlsbad, which is in the northern part of the Black Forest. We have also headquarters in the USA, China, and Japan. Our production, oh, it's not working. Can you click, Monica? Thank you. So we have 4 headquarters. In addition, we have 6 national subsidiaries and 23 tech centers so that we can provide our services worldwide and be very close to the customer. What you see here is a sketch of our headquarters in Carlsbad. We also have our production here. So we are 100% made in Germany, which is very important for us to really provide you with this quality, which Made in Germany nowadays stands for. Currently, we have 620 employees worldwide in these 4 headquarters and subsidiaries. Now it's working okay. So what are we actually providing? So Herrmann Ultraschall has like whole machines, which you see here as a sketch, but we also provide parts for ultrasonic sealing. Of course, our core product, the generator, which I will later on explain how it works and why we need this for ultrasonic sealing. So without generator, there is no ultrasonic sealing. Then we have the parts like converters, the sonotrodes, we have handheld systems, we have modules. So that's what makes up our product portfolio. Herrmann Ultraschall was founded in 1961 by the father of the current CEO. Back then, there were a lot of ultrasonic equipment on the market, but there was no real working generator. And he was sure that he could make one that was the best in the market, which he managed to do. So basically, the generator is our DNA. So that's where we came into market, where we came into being with the first operational, reliable ultrasonic generator. Nowadays, the generator, of course, isn't only hardware, but also, as in every aspect, as software becoming more and more important. You need to imply different functions, which are also easy or quicker to develop. And for all that, developing new functions in software or in mechanics, of course, we need bright, great people. We call them our genius minds. And they also contribute to our ultrasonic engineering. So our approach is to provide you with the perfect solution for your problem. And now it works. So in a box, we have the idea, we have a problem, we have the application, and we have an idea from our side. And together, we want to solve this for you. Herrmann Ultraschall is divided into 4 business units which serve 8 industries. So we have the business unit plastics, which are focusing more on rigid plastic parts, so big plastic parts like you see in the picture, automotive, medical, gardening tools, whatever you can imagine. Playmobil, for example, also. Then we have nonwovens, diapers, the face masks we all loved during the Corona pandemic, things like that. Our newest department is metals. So that's also wire-to-wire terminal applications, welding of batteries, and wiring harnesses. And the business unit I'm based in is packaging, of course, as we are also today in a packaging seminar. And we are focusing on flexible packaging, carton packaging and stuff. And I will go into that in my presentation. Herrmann Ultraschall is one or even the world market leader in ultrasonics. And our goal, of course, is to stay in that role. And we want to achieve that by really following our why. So we were putting a lot of thought into why are we doing this. And for us, it's bonding, but not only bonding materials, but bonding more than materials, bonding with our customers, bonding with our suppliers, bonding with people we're working together with, like MESPAC, which are customers, but also partners, of course. And yeah, so that's why we're very happy also to have this webinar, because I think it's a very great example of bonding. And yeah, so much about Herrmann. And now I actually would like to use the opportunity, having such a big audience today, and asking you, it's again not working. Monica, could you? Thank you. If you actually already have experience with ultrasonic sealing, so is it totally new to you? Do you have experience but you're not using it? Or you have experience and you're actually using it already? I think Monica, so I see the monomaterial Paul here at the moment.
Yeah, one moment, sorry. Sorry.
If not, we start with that one.
Yeah. If you don't mind, we will start with that one.
I don't
Okay.
mind. So my other question would be, as monomaterials will also be a part of this webinar a bit, and Monica already mentioned with sustainable materials. So we would be interested if you are facing issues when sealing monomaterials. So maybe you don't seal them at all. So of course you don't have issues, but yeah, so you have the answering options, and it would be very helpful if you could vote. Thank you.
Okay, we will wait. So just 5-10 seconds. Okay, please vote, and we will see the results. Okay. Here we can see the results. Can you see the results?
No.
No? Okay. Okay, just I want to show you that there are 43% people vote that the last one. Okay. No, the first one, sorry. The 43 people vote that we do not seal monomaterials yet, 43% of the audience. Then 22% of the people vote we have no problems with monomaterials, and 22% we have increased burns and wrinkles, and 13% we have an increased amount of leaky pouches. Okay. So let me go to the other one. Okay. And now you have the opportunity to vote for the experience. So if do you have experience with ultrasonic sealing? No, yes, but don't use it, or yes, we use it. Okay, the people is voting. And okay, I think that a lot of people have already voted. So we final the stations. I don't know if you can see now.
Now I can see it, yes.
Okay, perfect. So you can see the results, that there is 68 people that said no, and 20% of the people said yes, but we don't use it, and 12% of the people said yes, and we use it.
Okay, perfect. So thank you for voting. It's always very helpful for us also to know who we are actually talking to. So as it's more than half of you who don't have experience with ultrasonics, I think it's very good if we repeat or if you learn what we're actually talking about. So what is ultrasonics? So as I already mentioned, we have the generator, which is like our core product, the heart of everything. And we need that to actually even get ultrasonic. So we need a high frequency current. So we have our normal current we get out of the plug, which in Europe normally are the 50 hertz, 230 volt. And of course, you see 50 hertz, that's no high frequency. So that wouldn't be ultrasonics. Then our generator converts, it changes, it generates the high frequency. That's why it's called generator. And normally we use either 20 kilohertz, 30 kilohertz, or 35 kilohertz. That's why we also have generators in those classes. So in packaging, most of the time it's 30 or 35 kilohertz. 20 kilohertz, it's for thicker materials. So packaging materials normally is very thin, so we don't need, so we need a higher frequency which has less energy. With that frequency, we go into our system. So we have the first thing is our converter, and that's the part where actually we get this ultrasonic, so this electrical oscillation converted into a mechanical oscillation. So with an electrical oscillation, we can't seal, can't weld. We need a mechanical movement, and that's happening in the converter. So there's piezoelectric ceramics in there, which expands and contracts when you apply the currency. And in a very small movement, you see it's only 9 micrometers. The next up in the stack would be the booster. It's optional. If we want a bigger amplitude or a smaller amplitude, we add a booster. And last thing is the sonotrode. And again, here we can have a shift of the amplitude. Also important are those points. Can they see my mouse? Can you see my mouse? Okay, perfect. Those points, because as you see, there is no movement here. So the oscillation is only in between these areas. And here there's no oscillation. So that's the point where we can fixate the stack. So if we put it into a machine, that's where we apply the fixtures. And in the end, the sonotrode, kind like really a hammer, it's hammering on the anvil. And anvil is the counterpart, which also we provide. And with this hammering, we create heat. So we'll go to the next slide now to show you that it's not working again. Monica, could you please? Thank you. So here you see that would be the sonotrode, that would be the anvil. And if we start the movement, then we get from the hammering, we get heat inside. So there's friction on a molecular level, which creates heat. And this heat and friction, so the molecules, they bond, and we have a very strong bond with the heat generated directly where we need it inside, and not like with the heat where we have to get it from the outer layers to the inner layer. Could you click again, Monica? I think it's system doesn't like me today. I think you went out of the presentation.
Yes, sorry. Okay. Okay, just one moment. I'm sorry because internet is not working very well to me. Just one moment. Okay. I'm sorry. Was this one?
That would be the next, yeah.
The next one, okay.
Yeah.
Sorry, we had internet issues, but I think that it's solved. Sorry.
No worries. So now, after a quick introduction how ultrasonic sealing actually works, here we have a first video of a sealing through, that's pet food. Looks very nice. But what is really nice is that, as you see, so we see through all the food and stuff, so we don't have any issues with the contamination here. So that's one of the big advantages of our ultrasonic sealing. Thanks to this capability of sealing through contamination, at one customers we actually achieved a reduction of food waste of 4,430 kilogram, which is the size of a grown African elephant, which we could save per day. So it's on all their plants in Europe, so it's a big company. But still, as you see, it's 40 to 200 liters in 100,000 compared to 100 liter in 100,000, which would be then 21 kilogram, which still is enough food waste, I think. But still, I mean, an elephant per day, it's quite the achievement. And short calculation for you, I will make it quick because otherwise we run out of time. So just the numbers, we had 60 cycles, 3 shifts, 22 hours per day on 4 lanes. So we have 316,800 pouches per day. And if we, the pouches had 100 gram content, and that's how we added up to the numbers I showed before. Then another challenge, apart from food waste, we also want to say, so in general, we want to save resources. One of the resources, food, another one is energy. With heat sealing, we have the problem that the tools always have to be on a high temperature. So they always have a high energy consumption, and they have a heat up phase where they consume energy before you actually can use them. With ultrasonic sealing, we have the advantage that it's instantly on, so there's no heating up required. And the main energy consumption is only during the sealing. There's a minimal idle power for the generator, but it's not much, as you see in the next calculation. So again, we take the 60 cycles per minute. We have an active sealing time of 20%. with the ultrasonic sealing. Heat sealing, well, need to have it on all the time, which for an hour makes 12 minutes for the ultrasonic, 60 for the heat. If we add it up, 2 shifts, 16 hours, we end up with a power consumption of 300, or we have a power consumption, of 300 watt and 500 watt per day. It's 1 kilowatt hour, for the ultrasonic sealing, 8 for the heat sealing, and per year, yeah, I mean, if you scale it, and the difference gets even bigger. And in comparison, it's, could you click, Monica? It's not, yeah, now it's there. It's 88% less energy with ultrasonic sealing than you have with heat sealing. So it's a very big decrease. And with the increasing energy prices, I think it's a thing worth looking into. This number also comes into play, or you see it again with the CO2. So CO2 is going to be kind of the new currency. So as there will be fees if you have too much, too big CO2 print and everything. So we want to save this resource as well, of course. And in this example, it's linked directly to the energy consumption. And if we take a mix of energies we had in this example, so we could say that per day we have an CO2 of 430.2 gram, which doesn't sound a lot. Even with heat, it's roughly 3 kilogram. But if you add it up for a 10-line production for a year, it adds up. And again, here, of course, we have the 82% as it's a linear calculation, which we can reduce in emission, but we can increase the sustainability very much here. We implemented a TCO analyzer for you. So if you are interested in what you can actually save when implementing ultrasonic heat sealing, please reach out to either Victor directly and he can get in touch with us, or at the end, we will also share our sales contact with you who will be very happy to help you. Now, a quick look on sealing monomaterials, just a short recap. Nowadays, still most of the materials are multi-layer materials, which means we have different plastic types. Those plastics, they have different melting points, different properties, and therefore it's easier to seal them because often you have the one with the highest melting point on the outside, the one which is more temperature sensitive on the inside, and therefore they're not as sensitive to the heat or the problems which the heat would cause on the monomaterials. So monomaterials, as the word says, they're made up of one material, so they all have the same melting point. And if you have to get the heat from inside out, well, the carrier layer melts before the inner layer melts, which we don't want, of course. And if you remember the video I showed before, with ultrasonic, the heat is generated inside, so where we need it, and not transferred from outside in. That's why we have less problems with wrinkles and burns and stuff with ultrasonic sealing. Yeah, it's basically what I just said. I've reached a bit in front. So challenges with heat sealing are melting carrier layers, untied or leaky pouches, bad optical appearances, and the advantages as mentioned, we don't have the heat transfer, therefore we have a lower risk of melting carrier layers, we have a minimum to non-film shrinkage, and we have a precise control of the energy. Also with the monomaterials, we have smaller process windows, and it's more difficult to control them with heat sealing. With ultrasonics, with our generators, which I mentioned before are smart, we can control the small process window very nice. So here we have our standard pouch. We've been doing the hermetic seal, so the thin line, for a while for many companies due to the advantages like sealing through contamination I mentioned before. But now with monomaterials upcoming, there's been more inquiries also to seal the cosmetic seal. So as cosmetic, it wasn't important if it's tight or not. That often was done by heat. But now with the monomaterials, we have the problem that we have this not nice optical appearance with the wrinkles and stuff. And of course, for a cosmetic seal, that's not what we want. So we developed a station, which I would like to present you. So we have our top seal module, where in a first step, we do our hermetic seal. So that's we've been doing for some years now. And then we've added the cosmetic seal, and it's all in one step. As you see, we have the anvil for the hermetic seal first. When that's done, it's moving back. The cosmetic seal is moving forward, and we have two nice seals in one station. Here you see a typical horizontal form filling machine. We have, like if we have a station with cosmetic seal. Monica, could you click? It's not reacting. Thank you. We have the hermetic seal. We have a station for the cosmetic seal. And as we're talking about heat, we need a cooling station as well. Now you can, thank you. With the cosmetic seal, or the TSM cosmetic, we can eliminate those two stations here and just have one. So we have the hermetic and the cosmetic seal in one station, and we can skip the cooling station because it's not hot. Like that, we will get a machine with a smaller footprint, or we can add optional new functions like an additional filling, steam injection, whatever your heart desires. So let's have a short look on the module, how quick it's actually working. So here's a pouch. We put it in, so that's in our lab, the video, and that's it already. So you've seen the movement, they are very, very small, very fast. We have a nice hermetic sealing and the cosmetic line. So in a nutshell, sealing monomaterials on the TSM COS, you get a safe and consistent sealing, a visually attractive pouch, and you get 3 stations in one. You have the hermetic sealing, cosmetic sealing, and a cooling station in one station. So at the end, I would like to give you a short overview. What are typical applications? So in general, we can seal flexible applications, which would be like the longitudinal seal on pillow bags and the cross seal on pillow bags. We could seal top seal chain bags, sachet sealing, and as mentioned, the hermetic seal and the cosmetic seal. So those aren't all done with the module I presented before, so we have different modules for that. And then we also have modules for cap sealing, so closures and fitments, so we can seal caps, and also valves like in the coffee bag. And with that, I would like to hand over to Victor to present you how Mespac is integrating those solutions into their machines.
Thank you, Miriam. Thank you for your great explanation. So now we want to have a very short discussion on what are the current integrations that we're doing of the Herrmann technology into standard Mespac machines. First of all, the purpose. So why should we combine Mespac technology with Herrmann technology? So it has proven to be a really good solution to ensure reliable sealing, a good performance. It can be easily integrated into a standard machine without having to do major changes, a major impact in the design. And it really helps drive up the efficiency of the machine by significantly reducing the amount of leakages or rejections we have due to quality-related issues. Usually in the standard application, what we do is we replace the first top sealing station by ultrasonic sealing. And why the top sealing station? Well, usually we use ultrasonic technology as a mean to defeat contamination on the top seal area. Usually contamination happens after the pouch is formed, so vertical and bottom seal have already been performed, and the only missing one is the top. In intermittent motion machines, especially when you have large machines with large volume of products, while you're moving the pouches in an intermittent way, you're transferring a lot of the inertia of the machine into the pouch, so the liquid can move around and splash or contaminate the top sealing area. With the standard thermal sealing, sometimes we find that we have complexity on achieving a good quality seal, while with ultrasonic technology, we ensure that we always have a good quality seal regardless of the potential contamination of the top sealing area. And then we use a secondary thermal sealing station because of cosmetic reasons. But as Miriam already explained very eloquently, this can be removed by their solution, so we can reduce that thermal sealing and cooling and have a more optimized layout of the machine. Why do we need this thermal sealing afterwards? Well, as also Miriam explained, ultrasonic technology provides a quality tight seal, but it's a continuous line. So if we only would apply ultrasonic sealing at the top seal, we will have a lip open at the top of the pouch. And usually this is perceived as a lower quality delivery. And we want to provide a really high quality outcome. That's why adding this thermal sealing ensures to have this premium look and feel. But again, this can be upgraded to Herrmann's system. What are the typical applications we do? So we usually use ultrasonic technology for liquids, for liquid applications, especially focusing on large throughputs. Usually large throughput means that we have very large machines, a lot of inertia transferred into the pouches, so it means splashing, a lot of wave effect of the product inside of the pouch. So when we want to ensure that we can run at 50, 60 cycles, 65 cycles per minute, which means productions between 200 and 300 pouches per minute, it is a really good option to minimize the having to reduce the speed due to contamination related issues. It has to be said, though, that we usually recommend using this solution when we have applications where we don't need to have significant changeover in width. Usually this ultrasonic technology works great, but we need to have a dedicated anvil and sonotrode for each specific width. If we need to do this as a part of the changeover procedure, it can potentially increase a lot the changeover time and the complexity. That's why usually in this kind of project, we suggest to keep a consistent width of the pouch and play with the height to deliver the different formats. We usually use this technology, especially for standard pouches, both with or without spout, and also can be used for sachets or stick bags, as Miriam already explained. We use this technology on the top seal, not on the vertical seal on the bottom seal. The reason being that we don't want to have a scenario where we are transitioning from a 2-layer, like the one we have in the vertical seal, to a 4-layer like we have in the gasset area. This change in thickness of the film really is a big challenge to overcome for ultrasonic technology. That's why we limit the application to the top seal. Finally, although most of the applications are top seal related, we also use ultrasonic technology when we need to apply spouts or valves in the front side of or the back side of the pouch. So the most typical application is a frontal spout. You can find this application very typically in Latin America. And also we can use the same technology for frontal valves, mainly used for coffee related applications. This has proven to be a really good solution for monomaterials. As you know, monomaterials have a narrower window of operation when we need to apply thermal sealing. The range of parameters that we can use for monomaterials gets significantly reduced compared to standard applications. So having a solution that doesn't rely on temperature really helps us to deliver this good quality result. Miriam has not explained that. I think that you will be able to explain that later in the Q&A, but they are also have been working really strongly on paper-based applications, even for paper-based applications where the paper has 0% content of plastic. So this is something that we can also explain on the Q&A. Long story short, the key takeaways. Ultrasonic technology is a great way to reduce the waste which is inherent in the machine, to minimize the leakage so we can produce higher quality and therefore higher efficiency. And it's a great way to approach sustainable packaging, especially when we have liquid-related applications. Now we're going to show you a video of one of the latest applications we have delivered a few months ago. This is a quadplex machine, carousel machine for liquids. It's a very high throughput. We're talking 60, 65 cycles per minute for 1 liter pouches. And in this case, we were doing continuous sealing. So we're doing continuous filling and continuous sealing, which creates even added complexity to the ultrasonic process. And we were doing this in a 2-row scenario, having 2 sets, front and back, so 4 sets of ultrasonic technology at the same time. That's all from my side. Here I'm open to answer all of the questions that you may have. So, Monica, all yours.
Yes. Okay, thank you very much, Victor and Miriam, okay, for your explanation. And now it's time for the Q&A from the attendees. And there are a lot of questions today. And remember that you have the opportunity to write your questions on the question and answer section that you can see on the menu. So there is one question. The first question is here that I would like, yeah, sorry. I would like to know more about the ultrasonic sealing on the paper. Could you explain it a little bit more?
So if you mean like the only paper, that's something we are working. It's actually in our application development at the moment. So we have a patent on that. So we're actually also the only one who are working and are allowed to work on that. And we could achieve very strong bonds at the moment, but we are not at a point to implement it in a machine yet. So we're on a very good path forward here. We're very confident that we have a great opportunity and a great technology for that. But for sealing pouches, it's too early, I'm afraid. What we can seal are the type of pouches that Victor showed in the video, of course, because they're laminated inside, and that, of course, we can seal. There's no problem here.
Okay, thank you. And more questions that we have from the audience is, where do you see the main limitations of sealing through contamination?
So if we have, like we had a customer in the US, which are packing chicken soup. And of course, if we get like a bone stuck in the area, that's something we cannot see through. So we would need to be able to crush, basically with the force we implement, we would need to crush the material if it's rigid. And as soon as that worked, and then we can get it out of the sealing area and can seal it. But if it's something really rigid that we can't crush and which is stuck inside, then of course we can't seal through it as well.
Okay,
thank
you.
Yeah.
Thank you, Miriam. More questions. Is ultrasonic sealing suitable only for liquid products, or can it be used with another types of applications as well?
So we are also in the pet food market, as I showed in the picture, ready meals. Basically, we can seal everything you want. The question if there's a business case. So if you really have contamination in the area, then we're your guy, I'd say. But if there's like if you have, for example, like snacks which don't do any contamination, then normally there's, unless you have monomaterials, not really the business case for using ultrasonic sealing. But from the type of product, there's no actual limitation. pH might be a problem, but for the material of the system we're using, not for the sealing itself.
Okay, thank you, clear. And more questions. Is ultrasonic sealing limited to the top seals, or can it also be used for other places of seals like side or bottom?
Well, as
Well,
we
as
explained, yeah, I
sorry.
can take this one, Miriam.
Yeah,
You're taking
yeah.
everything. I need one too. Now, as we mentioned, the biggest complexity with ultrasonic technology is the transition between layers. So if we change from 2 layers to 3 or 4 layers, that point of transition is going to be a challenge. So that's why we usually don't recommend that. Also for bottom seal, even in doypack kind of applications or standard pouches, we have shaped bottom seals. So this is something that we usually don't do or cannot do with ultrasonic technology. Miriam, correct me if I'm wrong, but usually it's a more straight line what we can produce with ultrasonic technology.
Yeah,
Okay,
it's easier. Yes, absolutely.
perfect. How easy can ultrasonic sealing be retrofitted onto existing heat sealing systems?
It can be retrofitted. Of course, we will need to remove the existing thermal sealer, the first station, but then we can provide an upgrade with ultrasonic technology. Probably will work as a standalone system, so we will be able to interlock it with the existing technology regardless of how old is the machine we are retrofitting.
Okay, more questions. Our main issues is sealing at triple points and crashing zipper ends. Could you support us?
Well, as we mentioned, this is the typical case where we have a transition in thickness. So this is one of the main challenges that ultrasonic technology has. I don't like to always say a straight no or a strong no. We will need to test it and evaluate the solution. But from a start, I will say this is not the typical application we use ultrasonic technology for.
Okay, more questions. Can ultrasonic sealing be applied to complex shapes or just not just in a straight line?
So I wouldn't recommend it. So we can, of course, shape the anvil, but it's always it adds complexity, and we normally it's not the applications we prefer. Let's put it like this.
Okay, clear. Is it also possible with pouches with spouts?
Well, we already have said that we can do valves or frontless spouts. If we're talking about corner spouts or top spouts, this is something that I know the Herrmann team have been working for a while, but I'm also pretty sure it's not ready for the market yet, right, Miriam?
Yeah, so we're working on corner spouts.
Mm.
On the spouts in the middle, honestly, I don't see it in the near future. So the corner, we are working on that, but the spout in the middle, it's basically the same problem we have with layer jump. So if we go to from 2 to 4 layers, yeah, we have, it's just what are our advantages with monomaterials and the contamination are, on the other hand, our limitations here. Yeah.
Mhm.
Okay. What materials can be sealed with ultrasonic sealing? Non-woven fabrics, coffee pads, yogurt, milk, cups. What are the limits of your application?
So as I explained when I presented the company, we actually have a business unit, nonwovens, which are focusing on nonwoven materials. So in general, we can seal anything if it's I think it's called a thermal active plastic. So if it reacts to temperature, then we can seal it. Um, Yogurt cups, we're also working on that, on so peelable lid on yogurt cup, for example. That's also one of a project which is in application development from our side. What were the other points? What were asked for? So in general, I'd say the
Mhm.
limitation. We need to find out. So the material, they all behave differently. So we actually sometimes we encounter problems at factories which are running really great for a while, and then if we talk to them closer and ask, did you change packaging material, and they're like, no, we didn't change. And then they ask their supplier and they said, yeah, we changed a tiny thing, and then already the process window changed. So you see, it's very that's why it's difficult to say in general which material we can and we can't. So for every material which can be activated with ultrasonics, we can seal it, but we just need to find a process window and the the right way.
Okay, perfect. Thank you. We're running the PE and nylon, so this is multi-layer. Do we have technology for this?
As long as it has the ability to hit with the ultrasonic movement, yes. So that's the whole purpose.
Okay. This is a large one.
Mhm.
We currently operate an intermittent motion vertical form fill and seal machine equipped with a 600 millimeter wide thermal sealing system. We are exploring the possibility of converting this machine to ultrasonic sealing. The first question is, could you let us know if such a conversation is feasible?
So technically, yes, there are vertical form fill and seal equipment that can be used ultrasonic sealing both for the vertical seal and the horizontal seal. Uh, it's true that MESPA provides BFFS equipment, but we have not produced the past vertical form fill and seal equipment with ultrasonic technology. It doesn't mean we cannot do it. It just means that we have not done it yet because we have not found the right project.
Okay. Um, Excuse me, maybe they said it and I didn't understand, but what is there for multi-layer material?
So multi-layer material is the best case scenario. If we
Mhm.
have multi-layer material, it's going to weld for sure.
Yeah, okay, it's not monomaterial. Yeah,
Mhm.
it's not recyclable. So, is there any developments for vertical sealing?
Well, as mentioned, this phase change between 2 layers and 4 layers, it's a complexity. It doesn't mean it cannot be done. It means that it needs to be tested first and validated. This is for gazetted applications, of course. If we're talking about non-gazetted applications, it could be considered. Although you have the problem again that the seal is a straight line, a narrow line, and we will need to produce two seals, one for each side of the pouch, so we can have a tight pouch in both sides. This is something we have not done in the past, but it can be explored if the application requires so.
What about the cost of maintenance comparing heat sealing with ultrasonic sealing? Is higher, is less?
So I'd say in general it should be less because we don't actually need maintenance. So there's the anvils and the sonotrodes, they have to be reworked after some million cycles. So we don't have exact numbers because it strongly depends also on the type of pouch and the application. But if you compare it with heat sealing, where often they have these Teflon stripes which have to be changed, you have the cooling down phase, heating up phase, or the time where the machine can't run. I'd say it's much cheaper. So I can't give you exact numbers on that. It's also something you could have a look into with this TCO analyzer, because it strongly depends also on your machine and your case. But in general, it's less with ultrasonics.
Okay, fine. Can you seal through the cosmetic cream?
Yes, I don't
Yeah.
see why not.
Okay, perfect. Um, for supply zippers, we would like to know whether ultrasonic sealing can help in sealing zippers.
There are some zippers that can be welded using ultrasonic technology, but Miriam, correct me if I'm wrong, but these are dedicated zippers. They are special zippers, right?
So we have some experience with zipper sealing and zipper crush, but again, that's not our favorite applications. It's very challenging, and as you said, there's different kinds of zippers, and you have to like nearly have a solution for every single one, which doesn't really make it worthwhile for us.
Okay. Um, what about the spout sealing? Do you need a specific spout profile?
If we are talking, yes, yes, it doesn't matter if it's front spout or corner spout. Yes, and especially spouts, even if they have the same shape. They are highly dependent on the factor, on the tolerances. So it's very important that we have an application-specific solution for each one.
About the spouts, can you use ultrasonic to seal spout to the pouch?
Miriam already answered, yes, both for frontal spout and corner spout, but the corner spout is a considerably more challenging application.
Okay. And will this machine work with another machine in MESPAC range? For example, the H260 or different machines?
I will basically discard this solution for the smallest machine, but everything above the H180 can potentially use ultrasonic sealing technology for the top seal.
Okay. And can ultrasonic be continuous roller type sonotrode? In this case, for monomaterials, what will be the linear sealing speed?
So we have a module for that. It's called our longitudinal sealing module fin. So it's for the back actually normally. And I'm not sure. We had a customer here 3 weeks ago, which achieved amazing speeds. It was several hundred meters per minute, but this was really a best case scenario, but it can be very, very quick.
Mentioning that this solution can only be used when the film is continuous, when it has not been cut yet.
Yeah, sure.
Because as soon as you cut the pouch and you itemize the pouches, then you cannot have a transition between pouch no pouch in the continuous roller. It needs to be constantly fed.
Exactly.
Okay. So there are too many questions, so we don't have a lot of time. So one more question. Any risk to consider for health or for operator?
No, there should not be any concern because the system is placed inside of the machine. The machine comes with a safety compliant system, so there are interlock doors. There's all the safety requirements to make sure that we can operate the system safely.
Okay, so we don't have so much time to answer all your questions here in direct, but you can contact to our people from Herrmann and MESPAC, Victor Buguña. You can here see his email, and from Herrmann, apart from Miriam, there is here the Ruben Casa that you can see, or you can scan this QR and you will have the contact, and we will answer you in private because we don't have too much time. And we would like to thanks Miriam and Victor, and thanks to all of you for your trust and for being with us today. We invite you to contact them, or if you want, you can send us an email to mespac at marketing at mespac.com if you want. And if there is any question here, we will go to Victor or the people from Herrmann to answer you. And thank you, Victor, Miriam, again for your professionality, and this has been a topic very interesting for our audience, and looking forward to seeing you in the next Smart Talks. Thank you very much.
Pleasure. Happy to be here.
Thank you. Thanks for inviting me.
Bye-bye.
Have a nice day.